Okay, in 9-7, we're actually not doing anything new. We're just applying scientific notation into some word problems and real world problems. So I'm going to go through a few of them with you. There isn't really one way that you do these. I am going to require on the test that you turn the numbers into scientific notation and use operations with scientific notation. Um, on the test, you won't be able to have a calculator, but I'll make the numbers really nice to work out for you. So the first question says last year the local sporting goods store sold 1,250 wristbands. If each wristband cost 75 cents, how much did the store earn? So over here you'll see I changed 1,250 into scientific notation and 0.75 into scientific notation. Then I decided that I needed to multiply those to figure out how much they would cost. So 75 per wristband, 0.75 per wristband, I'm going to multiply those. So learning what we did the last time, I multiplied 1.25 by 7.5. I multiplied 10 to the third times 10 to the negative 1, and I got 10 to the negative second. Then your last step is to double check that your answer is in scientific notation and that you labeled it. So very important to make sure you labeled it. So they would earn 9.375 times 10 to the second dollars, which is about $937.50. All right. If a magazine sells for $275 and 3 million were sold last month, how much was made? So again, you'll see I changed 3 million into 3 times 10 to the sixth. There's a page in your book in the scientific notation section that has the powers for thousand, million, billion, trillion. They all go up by powers multiples of 3. So 3 million is the same as 3 times 10 to the sixth. 2.75, I didn't need to move the decimal at all to get it in proper scientific notation, so it's the same as 10 to the 0. And we already learned that anything to the 0 power is 1, so we're really not changing that. So I multiplied the 2.75 and the 3, the 10 to the 0 and 10 to the 6. So I add the exponent 0 plus 6. And I got 8.25 times 10 to the 6 dollars. All right, in this one, let's see. We'll see if you guys can remember what this was called from your history classes. In 1803, when Thomas Jefferson was president, the U.S. purchased about 5 times 10 to the 8 acres of land from the French for 15 million. About how much per acre did the land cost? So I took the 15 million and changed that. Million is times 10 to the 6th, and then I can't have 15, so I moved it over once. Changed it to 1.5 times 10 to the 7th. I want to know dollars per acre, how much per acre. So I'm going to divide the amount of dollars by the number of acres, which I did here. So 1.5 divided by 5 is 0.3. 7 minus 8 is negative 1, so 10 to the negative 1. To put it in scientific notation, I had to move it over. So believe it or not, when we purchased the Louisiana purchase, it came out to about 3 cents per acre. That is a deal. All right, now this is a problem with the national debt. This national debt is actually much higher than that. 15.3 trillion was probably 5 or 6 years ago. It's probably upwards 17, 18 trillion at this point. Maybe even higher. You can Google that. And even the population, this was from 5 or 6 years ago. Again, you could work the real numbers if you want. So if we were to pay off the national debt, how much would each person have to pay? So again, I took 15.3 trillion and I turned it into trillion is times 10 to the 12th, put it in scientific notation. Same with the 314 million. And how much would each person have to pay? That would be dollars per person. So I took the dollars and divided that by the people. Okay. Then I divided 1.53 and 3.14. I subtracted the exponents and put it in scientific notation. So that means that even this was a while ago, like I said. Each person, whether you're a baby, an adult, it doesn't matter, each of you would have to pay about $48,700 just to get even. Just to get even. So there's going to be a worksheet that you can work through. Again, you have to read the problem. There isn't like a standard way I can tell you always are going to divide or always going to multiply. You're going to kind of have to figure it out for yourself. Sometimes if you use smaller numbers in its place to try and help figure out what operation to use, that can help too. So that's the end of these.